Welcome back to the Deep Dive, the place where we take all the complex sources you share with us and distill them down into the actionable knowledge you need fast. You know, we've all been there. That sudden stomach-dropping moment when you're easing out of a blind intersection or trying to merge.
Oh, yeah.
And you realize you have, well, zero sight line on the oncoming traffic.
Yeah.
It feels like you're driving completely blind.
It's a genuine failure point in situational awareness, and it happens because your physical view is compromised, often without you even realizing it until it's, too late.
Exactly. Our mission today is a critical deep dive into restricted views and defensive driving. We're not just talking about mirror adjustment.
No, this is much bigger.
We're dissecting every single factor, from the architecture of the streets we drive on to the actual design of the car you are sitting in right now that actively limits what you can see. If you want a definitive shortcut to enhancing your safety and becoming far more informed behind the wheel, this deep dive is for you.
And when we talk about restricted vision in this context, we are primarily focusing on viewing angles.
Viewing angles, okay.
Yeah. It's an analysis of what sectors of our essential 360-degree visual environment are blocked, and crucially, what structural or environmental factor is doing the blocking. Understanding this whole landscape is the foundation of true defensive driving.
Okay, let's unpack this then before we even hit the ignition. What are the common obstacles, the environmental factors that are consistently working against our view?
The causes are incredibly diverse. They stem from outside the car, from the vehicle's design, and from inside the cockpit itself.
So all three areas.
Right. Starting outside, this is often most obvious in, say, urban and residential settings. Think about what restricts your vision when you approach a corner. It's not just the sharp turn.
No.
It's the two-story building located right up against the curb line, the high brick wall or fence, the massive overgrown shrubbery that hasn't been trimmed in months.
Oh, the shrubbery is a big one.
It is. Or even poorly placed street signs that cover an entire quadrant of your windshield. All of these severely narrow your visual angle, sometimes until you are physically past the hazard.
And I think the most common one, which we sometimes just forget to factor in, is the line of cars already on the street.
Absolutely. Parked vehicles are massive mobile obstacles. If you're pulling out between two high vans, they completely obscure your view of the curb, the sidewalk, and the oncoming lanes.
Right.
And when you are moving, traffic itself becomes the restriction.
Meaning driving too close to the vehicle in front of you.
Precisely. If you are tailgating a large SUV or a van, or worst of all, a commercial semi-truck, you are driving into a visual tunnel.
A visual tunnel, that's a good way to put it.
You lose all forward visibility of traffic conditions, brake lights several cars ahead, and any roadside hazards they might be seeing before you do. That restricts your time to react, which is, the definition of dangerous driving.
That makes perfect sense. Now let's talk about the parts of the car we can. Well, the parts we can't move. Those structural supports are necessities, but they are also absolute vision killers.
That's the core vehicle design element. For the listener, when we talk about pillars, we mean the vertical supports.
Okay.
The A pillars frame your windshield, the B pillars sit right behind your front doors, and the C pillars frame the rear window. They hold the roof up, but their thickness creates these permanent structural blind spots. And in addition to the pillars, you have to consider other design elements like high, thick headrests that block your rear quarter view, or a dashboard that is so large or steeply raked that it severely restricts your lower immediate forward field of vision. It makes it really hard to see objects close to your bumper.
And finally, the factors that are totally within our control but often ignored. What we allow inside the car. I know I'm guilty of tossing my sunglasses case up near the dash. That's an immediate visibility killer, isn't it?
It is, and it adds up so quickly. Passengers leaning in the wrong direction, coats hanging over the rear seats, or critically, cargo loaded too high in the back of an SUV.
Which blocks the rear view mirror.
It blocks the entire center rear view mirror, which should be your primary reference point for what's directly behind you.
That awareness factor becomes absolutely critical in high-risk zones, intersections, curves, hills, where all those external and structural obstacles combine.
Yes.
You have to assume you can't see everything, which means you have to actively seek the clear view.
That's the mindset shift we are aiming for.
So we've identified the problems, both inside and out. The good news is that the first and most immediate step in mitigation is adjusting your driving environment, mastering your cockpit setup.
This is foundational, and it's something every driver should adjust for themselves every single time. It starts with your seat height and position.
Okay, where do we start?
You need to adjust the seat so your eyes are level with the middle of the windshield. If you're sitting too low, you lose that lower field of vision.
And too high.
If you're too high, the roofline becomes a constraint on your upper view.
And what about distance from the pedals and wheel? That feels like it's both for safety and visibility.
It is. Your seat needs to be positioned so your knees are still slightly bent when you press the pedals fully to the floor. And, this is vital for safety, maintain that 10 to 12-inch distance between your chest and the steering wheel's airbag.
Right.
Getting this distance right ensures you can move your head slightly, which is key for pillar checks later, without straining or losing control.
Now we move to the advanced maneuver, the blind zone elimination technique for mirrors. This is the difference between a mirror setup that just shows you the side of your car and one that's a real safety tool.
This technique is designed specifically to eliminate the notorious blind zone, that frustrating gap where a vehicle vanishes from your rearview mirror before it appears in your side mirror.
Okay, let's walk through it slowly.
For the driver's side mirror, you need to lean your head over toward the driver's side window until your head is nearly touching the glass. While you're holding that position, adjust the side mirror outward so you can just barely see the rear quarter panel of your own car.
So you're intentionally pushing the mirror's field of view far to the left. Why is seeing the side of my own car so unimportant here?
Because if your center rearview mirror is properly adjusted, it already shows you the area immediately to your rear. Seeing the side of your car in the side mirror is just redundant. That space is better used to show you the lane adjacent to you.
That makes a lot of sense. We are using the rear view mirror for traffic behind us and the side mirrors for traffic beside us. So how do we handle the passenger side?
For the passenger side mirror, you lean your head toward the center of the car. So you're aligning your head roughly with the center rearview mirror.
Okay.
Then you adjust the passenger side mirror so you can, again, just barely see the side of your car.
And the benefit of this whole setup is that it drastically reduces the overlap between the mirrors. It integrates all three views into a seamless 180-degree sweep of the lanes behind you.
Right. It effectively eliminates that traditional blind spot where cars tend to hide. It's truly transformative.
It sounds like it.
And before we move on, we have to reiterate the internal factors. If you have adjusted your seat and mirrors perfectly, don't compromise that by loading cargo high enough to block the rearview mirror.
Or cluttering the dashboard.
Exactly. Every inch of clear glass matters.
We've established that the car is actively working against us through various design choices. Let's move now to how vehicle type dramatically changes the rules of visibility. What's fascinating here is how the physical structure dictates inherent restrictions.
It does. No matter how well you adjust your seat, vehicle class matters immensely. You simply cannot drive a low-slung sedan the same way you drive a massive pickup truck. This has huge implications, especially if you drive multiple types of vehicles.
Let's start with the big ones: SUVs, trucks, and vans.
These vehicles benefit from that high command seating position. It gives you excellent forward visibility. You can see over the vehicles in front of you, anticipate hazards sooner, but they suffer from massive visibility compromises. They typically have much thicker A and B pillars, and due to their height and width, their blind spots to the sides and rear are huge.
And there's also the issue of what you can't see immediately around the vehicle, right? The bumper zone.
Absolutely, the near field restriction. Because you sit so high, the length of the hood on a large truck means you lose all visibility of what's immediately in front of the bumper. It's sometimes called the cone of silence.
Wow.
And this makes pulling up near low walls, small objects, or, critically, small children, extremely dangerous, as they can just vanish from sight.
Then you have the total opposite end of the spectrum: coupes and sports cars. These prioritize style and aerodynamics.
Which means severe restriction. Their design uses dramatically sloped roofs, often resulting in tiny rear windows and very aggressive, thick C-pillars. The C-pillars are those supports next to the rear window.
And on a sports car, they can be huge.
They can be so massive they can obscure an entire vehicle when you're merging or changing lanes.
So merging visibility is severely compromised in a sports car, whereas immediate forward visibility is compromised in a truck.
Precisely. And sedans and hatchbacks sort of occupy the middle ground. They generally offer better all-around glass space, but they still struggle with the A-pillar blind spot when turning, and certain designs still have bulky C-pillars that impede merging.
The critical takeaway for you, the listener, is that if you borrow a friend's truck or rent a minivan, you must immediately adjust your fundamental driving habits. You have to actively compensate for its dramatically different sightline profile.
You have to understand where that car is literally stopping you from seeing.
Okay, now that we know the physical limitations, let's move to active driving techniques for dealing with those constraints. Here's where it gets really interesting, I think. Focusing on defeating the pesky A-pillar.
The A-pillar is a necessary paradox. Its thickness is crucial for structural integrity and for protecting you in rollover accidents or deploying side curtain airbags.
So it has to be thick.
It has to be. But that thickness is often just the perfect width to completely obscure a pedestrian, a cyclist, or even an entire oncoming car when you are making a left-hand turn.
So what's the simple active mitigation strategy for this?
It's the incredibly effective, yet rarely taught, lean technique.
The lean technique, okay.
At intersections, when you're waiting to turn or when entering a curve, you perform a quick, slight lean forward or backward in your seat.
Just a little bit.
Just a little. This movement shifts your head a few inches, which is enough to change your viewing angle and peer past the thick pillar, effectively clearing the zone the pillar was blocking.
So essentially we are using our own movement to turn a static permanent blind spot into a momentary clear zone. That slight shift ensures that nothing, no vulnerable road user, no oncoming car, is hiding right behind that pillar.
Exactly. And strategy is vital here. Reduce your speed near intersections. This simple action buys you the precious extra second you need to perform that lean check and compensate for the obscured view.
Especially for pedestrians stepping into a crosswalk.
Especially then.
Shifting to merging and lane changes restricted viewing angles are the leading cause of those sideswipe fender benders. How does a lack of visibility impact these maneuvers, even after we've adjusted our mirrors?
Well, even with an optimal mirror setup, compromised viewing angles impair your ability to accurately judge the speed and distance of vehicles approaching from the side or rear. Your brain needs consistent visual data to make that judgment call. If that data is broken up by pillars or poor mirror angles, you will inevitably misjudge the gap.
Which brings us back to the classic non-negotiable step that technology can never replace.
You must always perform a physical shoulder check.
Always.
Even with perfectly adjusted mirrors and the best technology, you need to physically turn your head and clear that absolute inherent blind spot before you commit to a lane change. If your headrest or B-pillar blocks the view, you adjust your head position until the view is clear.
And other mitigation strategies here would include signaling your intentions early.
Which gives other drivers critical time to react.
And maintaining a safe following distance, so you have space and time to execute the maneuver without pressure from the car in front.
Right, and if we revisit the internal obstructions, if your rearview mirror is blocked by high cargo, for example, you must drive as if you are piloting a commercial van. You rely entirely on your side mirrors.
Which is a good time to use those extra mirrors.
An excellent time. Use simple, passive tools like wide angle or convex stick-on mirrors to give you that necessary enhanced side view when the center view is gone.
We've talked about what we can do physically, but let's be realistic. Modern technology is now an essential partner, compensating for what the eye and mirrors might miss. Is this where technology has to step in to solve the problems that physics and car design created?
Absolutely. Technology steps in precisely where structural limitations are unavoidable. The most common and beneficial features are blind spot monitoring, BSM, and rear cross traffic alert, RCTA.
How do they overcome those physical limitations?
BSM uses radar or ultrasonic sensors on the sides and rear bumper to detect vehicles that are outside the driver's natural field of vision, particularly those lurking in the quarter panel blind spots.
The ones that the shoulder check is for.
Exactly. It alerts you, usually with a light in the side mirror, when you're changing lanes. It is a critical supplement to the shoulder check. And RCTA is a lifesaver when backing out of a busy parking spot. When you reverse, the sensors scan the area laterally, detecting vehicles or even pedestrians approaching from the side. It's compensating for the terrible side visibility caused by C-pillars and the cars parked next to you.
But these are supplements. They aren't flawless. What happens when we rely on them too much?
We have to remember that they're sensors. They can fail if they're covered in mud, ice, or snow. Relying solely on the alert system means you are ignoring the fundamental task of visual confirmation. You use BSM as a double check, never as a replacement for your own vision.
What about when internal obstructions like passengers or high cargo completely negate your rear view?
That's where digital rear view mirrors shine. They use a camera mounted high on the rear of the vehicle, displaying an unobstructed wide-angle feed directly onto the mirror display itself.
So your view is perfectly clear.
It's perfectly clear, regardless of how many people are in the back seat or how high you stacked your luggage.
And for those complex, low-speed maneuvers, like parallel parking a large SUV.
The 360-degree camera systems are transformative. By stitching together feeds from cameras around the vehicle, they create a bird's-eye, overhead composite view. This makes maneuvering in tight spots far safer, as it eliminates those large, near-field blind spots near the bumpers that we discussed earlier.
Preventing scrapes and avoiding things you just couldn't see.
Exactly. And we shouldn't forget active night technology, adaptive headlights. They improve visibility by swiveling the headlight beam in the direction of a turn, literally projecting light around the corner that was previously obscured.
So it mitigates that classic problem of driving into the dark when turning at night.
It does.
So if we synthesize this core knowledge, restricted views are an unavoidable reality of vehicle design and environment, whether caused by thick A-pillars, external structures, or high cargo. But they can be proactively managed.
That management involves 3 steps. First, optimize your cockpit with specific adjustments using the blind zone elimination technique for mirrors. Second, execute active maneuvers like the lean technique when encountering pillars. And third, strategically leverage technology as a necessary supplement to human sight, recognizing its limitations but appreciating its ability to detect hazards in areas we cannot see.
That brings us back full circle to the design paradox we touched upon earlier. Our sources highlight that A pillars, B pillars, and C pillars are getting thicker because they are vital for structural integrity and, critically, for protecting you during a collision.
Rollover protection, airbag deployment, all of it.
Right. The safer we make the physical structure of the vehicle, the more restricted our natural unassisted sightlines become. This raises an important question for you to mull over. How does this growing engineering need for vehicle safety, requiring thicker sightline blocking structures, force us, the drivers, into relying more and more heavily on complex electronic sensors and cameras to compensate?
And what does this fundamental shift mean for our core human engagement with the physical act of driving?
Think about that the next time you rely on a green light flashing in your side mirror.
Please like, subscribe, and get notified.